Hello everyone. So welcome to this playlist on integer programming, and here is a one more question that I'm going to solve. This is an integer programming problem, and how to solve it, I will try to see it. So on your screen you can see everything is given. So if you want to try on yourself by yourself how to solve this, you can pause the video now and you can look at the uh, details of the question and you can try it. Otherwise, you can follow me and I will be solving this problem and you can see how to do it. So here, let's read the question. So Bayville has built a new elementary school, increasing the town's total to four schools, A, B, C, D. Okay, so Addison, Beeks, Canfield, and Daly. Each has a capacity of 400 students. Okay, so the total number of students in each school is 400. The school board wants to assign children to the schools so that their travel time by bus is as short as possible. So we want to minimize the travel time. The school board has partition. So basically, and one more keyword is assigning children to schools. So it's basically an assignment problem like that. Uh, the school board has partitioned the town into five districts conforming to population density. So yeah, the students are present in five different places. So according to that, the average bus travel time from each district to each school is shown in the follows. Determine the number of children that should be assigned from each district to each school to minimize the total student travel time. So that is a question. So let's see how we can solve it. So in this case, one of the most important thing is the selection of variables. Okay, so I'll go to my notes. Okay. So here we have the districts. So what are the districts? North, so north, south, east, west, and central. North, south, east, west, and central. So these are the districts. And what are the schools? So schools here we have A, B, C, D. Four schools are there. Okay. So now let's denote this by a variable. Okay. So here I will write for simplicity. So there are five rows and four columns. So I'll be getting 20 variables, right? So x11, x12, x13, x14, x121, 22, 23, 24. So the first digit is a row and the next digit is a column. 32, 33, 34, 41, 42, 43, 44, and then 51, 52, 53, 5, sorry, 54. Yeah. So what is the notation? So Xij means students from district I going to school J. So in this case, I will denote 1, 2, 3, 4, 5. Okay, so the East district is denoted by 3, Central is by 5, like that, and the schools ABCD is denoted by 1, 2, 3, 4. Okay. So you can also define something like XED. That means number of students from East district going to uh, school D, but this is too much complex, so I just keep it simple like this. Okay. Now here, this kind of problems, you have to simply see row wise addition and column wise addition. If I do row wise addition, what happens? I will be adding x11 plus x12 plus x13 plus x14. So row wise addition, if I add, what is this? This is the total number of students in the north district because one represents north. So this is the total number of students in the north district. So this is number of student population or whatever. So now same way x21 so on like that I get for five rows five values. Now what this number should be? So now if I go back to the question, so there is a student population is there. So you want to educate all the students, you want to send all the students to school Therefore, nobody should be left out. So therefore, the x11, x12, all these things should be exactly equal to the 250. So okay, so this has to be exactly equal to 250. So like this, we will get five. We will get five equality constraints. So one for each district for student population. So this is what we get for horizontal addition. Now let's do vertical addition. So if I do vertical addition, what I'll get x11 plus x21 plus x31 plus x41 plus x51. So five terms are there here. What does this represent? So this represents the total number of students studying in school A, and this represents total number of students studying in B and studying in C and studying in D. Now, what is the information given about that? So if I go back to the question, uh, town has total four schools A, B, C, D. Each has a capacity of 400 students. Okay, so now the capacity of each, so that means each column should be less than or equal to 400, because you cannot assign uh, more students to a school more than its capacity. So this should be less than or equal to constraint. So like this, we will get four constraints like this. So five constraints with horizontal addition, four constraints with vertical addition. So you remember that. Now, what is the objective? So objective is to minimize the distance, not the distance, the travel time. And you look at the travel time, 12, 23, 35, 70. These are the travel times from, for example, north to Addison is 12, north to Beeks is 23, north to Canfield is 35, like that. So since we have like this uh, values given, you can simply do the multiplication, element wise multiplication. That means if I take the coefficient first line 12, 23, 35, and 17. So I'll take here uh, 12, 23, 35, and 17. So if I multiply 12 with this, and 23 with this, 35 with this, and 17 with this, I get a number. But that is not the final one. So you have to do it for all these rows. Okay, the second row is 26, 15, 21, 27, 21, 27, and so on. So like this, if you do, then you will be getting the entire travel time of all the students going to all the schools from all the locations. So that needs to be minimized. Okay. So now writing all these things in a handwritten thing, it will be time consuming. So let us quickly do it on an Excel sheet. Okay. So in the earlier case, we used to write down all the variables in a single row, but now I will do it slightly different. I will use the multiple this, since our problem has 20. So writing 20 in a single row, it will be too long. So what I will do, I will just define like this. So I'm selecting four rows and five columns, and then I will just go to coloring, and then I just color it a little bit. So now this one, let us say horizontally A, B, C, D. So these are the your schools. So I merge these cells, just or I'll leave it like this. So these are the schools. Now north, south, east, west, and central. So these are the districts. Okay, so I think let me get to the middle of the screen. So now this one, let's say if I give 45 here, that means 45 students from north region are going to school A, like that. Let's center justify everything so that we can easily read them. So go to home and select center justify. So but these are all unknowns. Okay, so this is what we have to find out. Okay, so now I will say here left hand side, and I will say right hand side. So I think I can even attach to this. So I'll just delete this. So if I add all these things, sum. So horizontal addition, if I do four numbers, so here it is showing 45, and if I drag this, so what is the horizontal addition? So just now I was explaining, if you go for horizontal addition, you will get the number of students in that particular city. So these are equality constraints. So here single quote and a equal to sign if you give. So then these are all the equality constraints which you need to satisfy. How many students in the North District? Okay, so refer to the question. So there are 250 students in the North District. So here you have to say 250. How many students in the South? 340, 310, 210. So 340, 310, 210. So exactly whatever is given in the data, I am writing here like this. So now I have defined five constraints here. Later we have to specify in the solver. Now do the vertical addition. Okay, so sum, and here only take the five items in the one column. So vertical addition I have done. Anyway, so this 45 you make it like 10, and just to show you, so here I'll making it 15 here, and 9 here. So here you can see horizontal addition 10 plus 9 we are getting 19, whereas vertical addition 10 plus 15 you are getting 25, and so on like that. Anyway, but all these values going to change, okay, with the. Now what does this represent? So again, if I refer to my notes, vertical addition, it represents the constraint of the school. Okay, so each school cannot have more than 400 students, because that is the size of this, the capacity of the school. So less than or equal to 400. So in this case, these are the four constraints we are having. And of course, you cannot divide the students into like a fraction. So it will be integer solutions. I think that's it. We have defined. Now the cost. Okay. So for defining cost, I'll go slightly right, and then I will enter the cost parameters here. Not cost, the travel time. Okay. So what is the travel time? Okay. So just I will write here same as it is 12, 23, 35, 17. 12, 23, 35, 17. Next one 26, 15, 21, 27. 26, 15, 21, 27. Next one I have 18, 20, 22, 31. 18, 20, 22, 31. 29, 24, 35, 10. 29, 24, 35, 10. And 15, 10, 23, 16. Okay, so 15, 10, 23, 16. Okay. So this, whatever I have just now written here, okay, let me just highlight with some color. So these are the travel times. Okay, so travel times in minutes. Now, if I do a product of these two, some product of these two, then I will get the total travel time. So here I will again, just for easy recognition, I am giving a green color. So is equal to some product, and I will select this entire yellow region, 5 rows and 4 columns, comma, and I will select the entire blue region. So it will do the sum product of both these things. Okay, so now based on this 10, 9, and 15, already it will multiply it with this, and already we are getting 817. This is what we need to minimize. Now we have defined everything. So let us now go to, I'll just save this. Okay, so let me call this as school. Now data, and then say solver. So here select objective. So I'm selecting this N11 as the objective. Maximize or minimize, I want to go for minimize by changing the cells. So here I am selecting all the yellow colored cells. enter. Now subject to constraints. So first again I will select these yellow colored cells and I will constrain them to be integers. So here I'll select integers. So then I will say add. So now here you can see D4 to G8 integer constraints are added. Okay, so the this thing. Now I have to add the constraint for school capacity, for example, less than or equal to. So I will say add and select the ninth row and less than or equal to, and here I will select the 400s. Say add. So cancel. So here I am getting the less than or equal to constraints pertaining to capacity of each school. Now I want to go for equality constraints. So I'm adding all this. Here I go for selecting equal and then constraints like this. So now the demand of the students. Okay, so number of students to be, so that equality constraints also I have added. So done. I have added everything. Now go for simplex linear programming and then simply say solve. So error in the model. Okay. I think the question mark is a problem. Just say OK. Just here you save it to 0. Again data solve. So better keep those cells empty. So again say solve. Solver found a solution. All constraints and optimal conditions are satisfied. Okay, so now here we got the solution. You see all this student demand. How many students from north? 250 out of 250, 340. All the students have been assigned. How they have been assigned? The 250 students of north region entirely everybody assigned to school A because 12 minutes is the minimum travel time. Then 340 students of south region, 300 have been assigned to B and 40 have been assigned to C. So depending on 15, 21 like that and so on like that. Finally, this thing. And if you notice here, all 400, 400 the schools are filled except that there is some more uh, vacancy or gap in the school C. More 200 students can be accommodated in school C. Okay. Again, if you notice, school C travel times are more. Okay. That means school C might be the farthest school, far away school. So that's why more is there. Anyway, so we solve the solution. This yellow region is our final answer, and the travel time, minimize the travel time is like this. Okay. So I hope you found this interesting how to solve. So based on this, you can see. So I hope your answers also match with my answers. So this is again, once again, the question. So I hope this is useful.